Welcome, Life Sciences. Welcome back from your wee break. I think you needed that after all that terminology after terminology after terminology. As I said to you, this is quite a challenging section that we are looking at. What are we looking at? We're looking at the human excretory system. And this time we are looking specifically, how does the kidney work? And it's a very intricate, it's a quite a complicated way in how the kidney, or little structures that we looked at inside the kidney, the nephron, how they are going to filter, all right, all of the blood. So look what we're looking at. The blood must come into the kidney, right? It comes into the kidney, and the kidney's function is to filter. And as I said to you, what I mean by filter, I need to keep the waste products and I need to get rid of what is good. I know that sounds weird, but what goes through our kidney to filter means I need to keep the things that my body still needs, and I need to get rid of the waste that could be harmful to me. And that is the function of the kidney. But the kidney is made up of a little structure called the nephron, right? And parts of the nephron, each got a little part in how it's going to, right, filter. So at the end result, we've got this waste product that we're going to call urine. Okay, that is where we're at. All right, oopsie daisy, going the wrong way. Right, guys, still a lot of terminology here, a lot of words, right, that we haven't encountered before. Just make sure that you understand how to use them, when to use them, and what they mean. So where have we been so long? So we have looked at, the first part that we looked at was glomerular filtration, and we had a look at this concept of the nephron is made up of the C-shaped capsule called a Bowman's capsule, and all the blood, right, let me change it to red, it's much easier, all the blood, the glomerulus that comes in here, and then we filter. Everything that is necessary that can fit through goes out of the glomerulus, the blood, and it goes into the Bowman's capsule. Then afterwards, we looked at the process of tubular reabsorption, and we have a look, there are tubes, right, round about all of the nephron, and usually in this first tube, the proximal convoluted tubule, a lot of the things that we still need, glucose, as I said to you, water, maybe some sodium, right, or minerals, we bring back reabsorption. We bring back into the blood. Our last process that we're going to look at now is called tubular excretion. Now, if we have a look at the definition of what it is, it's, if I were to say, it's the opposite of tubular reabsorption. So basically, let's look at our nephron again. We draw. We've got all these tubules, right? And they're carrying all of this filtrate. That's the word that we use. Surrounding this nephron, I'm going to draw it in red, we've got this blood supply that it actually looks like a tangled mess. But that is really important because why? When we looked at the processes over here, tubular reabsorption, if we go back again, we reabsorbed substances. What does that mean? We took the things that we needed. Now, tubular excretion means that in the blood, there is still waste products. Guys, this whole blood system that's surrounding the nephron, that's twisted, what do we still have in it? We're going to have waste products. So where must these waste products go? They must now go into the tubules. Look at my arrow over here. Tubular reabsorption, my arrow went out of the tubules. Tubular excretion is going to go back into the tubules. So when we look at this process, right, as I said to you, it's the opposite. If I go to this diagram over here, the one that we did earlier. So what is number one? Number one, right, was my glomerular filtration. what did I do? I filtered the blood. I filtered the glomerulus. Number 2, what did I have? Tubular reabsorption. I'm not going to write that. I'm just going to write out as far as that. And look at the arrow. What did tubular reabsorption entail? It entailed everything that I still needed. Okay, needed. It was reabsorbed back into the blood because I still needed it. But have a look at the blood. The blood is filled with waste products. And those waste products could still be maybe some urea, could be some uric acid or creatinine. And sometimes when we look at the concept later, you will see maybe some hydrogen. It's a way that our body is going to control the pH, and maybe even some chloride. Right, but what we find over there is, what do? We don't have it it's in the blood, and look at the arrow. Tubular excretion. And let's go back to that definition of excretion. What did excretion mean? Getting rid of waste products. And tubular means getting rid of into the tubules. So all of these things, all right, my body now no longer needs it. It's in the blood supply, and I then, all right, put it back into the tubules. So it goes back into the tubules. It usually can happen in the proximal convoluted tubule, but it usually happens a lot more in the distal convoluted tubule. That's where it's going to happen a bit more often than in the rest. Now if we have a look at this diagram, we can look at the whole process, right, in the bigger sphere of things. So number 1, if you can understand, glomerular filtration, right? So that is it coming from the blood into the glomerulus. Here, number 3, tubular reabsorption. I take what I need, or tubular secretion, I prefer the term excretion, right? Whatever I don't need goes back into the tubes. Now, guys, this leads us to this very last important concept. So, if everything came into the blood, right, and then entered the kidney, the nephron has this whole concept that it must filter. So by the time that it gets to, now let's have a look on my journey, by the time it gets to these last tubes, they are called the collecting ducts. Let me have a look at the next diagram, and I don't have to draw over here. Okay, so we've gone through our 3 processes. Here, the very last tube is my collecting duct. And what this collecting duct over here, when it gets to this point, okay, guys, what is carried in here is urine. And what must urine be? Urine must be all the substances that my body doesn't need. What was that? It was urea. It was uric acid. Right, it was creatinine. So it was all my creatinine, it was all my nitrogenous wastes. Right, what else could be here? If I had, right, drugs, if I had a headache tablet, or if I'm naughty and I do drugs, maybe some kind of colorants, right, maybe a hormone. So all the things that I didn't want, they are then present in this thing called urine. Now I've left out the most important thing, oopsie daisy, that we get when we get to urine. What else is in there? Water. We don't weed powder. When we urinate, it is water. And how do we get rid of this waste? We make sure that there is some water in these tubules that is going to be excreted. So imagine if I've got all of them and they each drip. I've got these millions, right? Millions and millions of nephrons. And they each drip something into the pelvis. and that pelvis, right, leads into the ureter. Where does the ureter go? The ureter is going to take all this and it's going to store it in the bladder. And when it's stored in the bladder, as I said, the bladder is going to stretch and our brain's going to tell us, lady, right, it's full, let us go to the toilet, and then we have a urethra, and then we go to the toilet. Okay, guys, so that is what we've looked at, this whole concept. It's a kind of like a bit of a mass thing. What went in, all right, was a whole lot of stuff. And then I filtered everything. Some of the stuff I needed, so I reabsorbed it, I took it out. Some of the waste that I hadn't collected, I put back in. And at the end, I had this substance called urine. That was the waste product. And the excretory system, the human urinary system, excretes and gets rid of this substance called urine. That is all we have time for. I hope you understood this. It is a difficult section. Until next time, cherry bye.